Welcome back to ChEM-O-NOTES, your chemistry companion for clear concepts and smart learning. We have already started with the rearrangement series. Today is part 2. We are going to study Pinacol-Pinacolone Rearrangement in cyclic system. In the previous first series, we have seen Pinacol-Pinacolone Rearrangement for a cyclic system. So if you like, please share the video with your friends and do like the channel. So let's begin. Grab your notebook. We'll start with the Pinacol-Pinacolone rearrangement step by step with mechanism. So let's start. So let's begin. We'll have a small recap of Pinacol-Pinacolone rearrangement that we have done in part 1. You will get the link of part 1 in the description. Please go and watch that video. Today we'll just see the recap first and then we will go for cyclic system. So what do you mean by Pinacol? Pinacol is nothing but a 1,2 diol, vicinal diol. You can see here on the screen, this is 1,2 diol. Okay, and the diol 1,2 diol is known as Pinacol. So this is your first carbon and this is your second carbon. First carbon contains OH group, second carbon contains OH group. That's why it is called as 1,2 diol. So 1,2 diol, when it is treated with acid such as corn, H2SO4, okay, it undergoes first protonation and then removal of water group, and which rearranges by 1,2 shift and we get a highly substituted ketone. Okay, we get a ketone. You can see here R, C double bond O, R, C, and there are 3 R groups substitutes. Okay, so this is a basic of Pinacol-Pinacolone rearrangement where a Pinacol is converted into, so what has happened, a Pinacol has been converted into Pinacolone. So this structure is known as Pinacolone. Pinacolone is nothing but your highly substituted ketone. Okay, in the presence of acidic medium, this reaction takes place. So this is the basic understanding of the Pinacol-Pinacolone rearrangement. In the previous video, the link is in the description. As I told you, you will find the detailed step-by-step mechanism for a cyclic system. Now, this is what you should understand before we go to the cyclic system. Selectivity in Pinacolone rearrangement. This is also there in the previous video, but I'll repeat once again. So here you will find this is your 1,2 diol. Okay, this is your 1,2 diol, where you will find that there are substitute is phenyl, methyl, phenyl, methyl. Okay, so in the previous video we have already seen how the carbocation, which one is the stable carbocation and how the carbocation is formed. All those steps we have seen. So in this part we will be seeing the selectivity of the Pinacol rearrangement. What you have to do, first step is the protonation will take place. Okay, so protonation will take place. For example, here both the, if you see on the first carbon there are same groups, on the second carbon also there are same group. So any one of the OH is going to grab the proton. So let us say this is the first carbon OH which has grabbed the proton, and it gets protonated first, and then after protonation it will, the intermediate step I'll show it here. What will happen, you will get OH, Me, PH, PH, Me, and here you are going to get O, that is after grabbing the proton it will become H2O plus, because it has used its pair of electrons, so oxygen will carry a plus sign. Now this hydronium ion is going to release, okay, to stabilize the plus ion. So from here you will find that it has been released. So this will get converted into carbocation by loss of water molecule. So here on the first carbon, that is this carbon, you will have formation of carbocation. Okay, so this you will get in the first step. This is your first path, path 1. In path 1, what we have done? We have shown that carbocation is formed on first carbon. Okay, and this is your path 2. This which, okay, so here what will happen after that? Carbocation is formed, rearrangement will take place. Shifting will take place. So in rearrangement, now the question will be there, which of the group will get rearranged? Whether phenyl group or methyl group. So who is going to rearrange itself on carbon 1? Okay. So if the phenyl gets rearranged, you will get this as path 1. What we are doing in path 1, phenyl group we are trying to rearrange. So phenyl group will rearrange here and it will try to stabilize the plus ion. So it is a 1-2 shift and you will find pH, pH, Me. So your phenyl group which was on the second carbon has shifted to first carbon. This is your carbon 1 and carbon 2. So we know that how the mechanism takes place. The electron pair of oxygen will shift here and it will push pH on the first carbon. And this way you are going to get a pinacolone or a ketone, highly substituted ketone, which is also known as pinacolone. Okay. So here path 1 and now let us see path 2. This is your path 2. In part 2 what is happening? That instead of phenyl, if the methyl goes on the shifts here. So 1-2 shift of methyl group. If it shifts, then you can see here on first carbon there are 2 methyl group and 1 phenyl, because the methyl group which was on second carbon has shifted and this is the product which you should get. But part 2 is not followed. Okay, can anyone tell me why part 2 is not followed? Why this product is not formed? This product will not be formed. Why is it so? Because of the selectivity. Okay, the group which is going to stabilize the positive charge more, like among phenyl and methyl, phenyl group is going to stabilize it more. Okay, that's the reason phenyl, because of its stabilization due to resonance, phenyl group is preferred. Here phenyl group is preferred over methyl group. Followed? That's the reason why you will be getting this product which follows path 1. So this is about the selectivity in pinacolone rearrangement. So you should always try to have all the type of products you will be getting and then select which is the most preferred one, which will be the most preferred product which is going to be formed. So in this way you have to see which group is going to selectively migrate or transfer from second carbon to first carbon, that is 1-2 shift. Okay, so let us study now the cyclic rearrangements. The rearrangements in cyclic system. So today's part 2 is specially for cyclic system. Now when bicyclic 1,2-diol undergoes Pinacol-Pinacolone rearrangement to give ketone, either ring expansion will take place or what happens, ring contraction may take place depending on the size of the ring. So basically two things happen in this, that is a bicyclic, you can see here bicyclic diol, it is undergoing Pinacol-Pinacolone rearrangement. The product is same, that is ketone. Only thing is either the ring expansion takes place or ring contraction takes place. Okay, so let us see. This is the example. You can see here it is a bicyclic 1,2 diol. So this is your first carbon, this is your second carbon. One ring is 4 carbon chain and the other one is 5 carbon closed chain. Okay, so this is 4 carbon and this is 5 carbon, a pentane, cyclic pentane and cyclic butane, and there is OH, that is a diol. So this will undergo Pinacol-Pinacolone rearrangement in the same way, step by step, that one of the group out of these will try to grab the proton and form a carbocation. So first step, as you know that first step of the Pinacol-Pinacolone rearrangement is formation of carbocation. So here you can find second carbon OH is going to grab the proton and you will get a carbocation. So in the first step you will find that this grabs the proton, then there is elimination of water molecule and a carbocation is formed on the second carbon. Why second carbon? That we have seen in the previous video, part 1. Go and see the link if you have not seen the video. Okay, just hit the link in the description and you can understand why the carbocation is formed on second carbon. So why this is preferred, that I have explained there. So there is a formation of carbocation, then rearrangement will take place. Now in the rearrangement, see what happens is, you can see here there is this lone pair will shift here and it will try to push one of the bond adjacent to the OH group to stabilize the carbocation. So here this bond is going to shift here to stabilize the carbocation, and 4-membered ring has expanded itself to 5-membered ring. You can see here, it was 4-membered ring. 4-membered ring is expanded to 5-member ring. Okay, I'll just write it again. Okay, that is this. If you can count 1, 2, 3, 4, 5, here the original second ring was 5-membered only. So this is your first ring, this is your second ring. Now what has happened to the first ring? It has become 5-member, whereas second is again 5-membered only. 5-membered, this has also become 5-membered. Okay. Now as it has used its oxygen has used its lone pair, oxygen will carry a positive charge, and then last step is deprotonation. Okay, deprotonation. So what will happen? This bond will break and electrons will be left over on the oxygen and proton will be removed or lost. So loss of proton. And the last step, you are getting a ketone. Now the pinacolon which has formed is expansion of the ring. So this way the cyclic system takes place. Now let us see one more example of cyclic system in the Pinacol-Pinacolone rearrangement. Now in the competitive exams like CET, NET, JEE, such type of cyclic Pinacol rearrangement system they ask. They don't ask the simple one. Okay. So all those questions which are asked in the CET, NET or JEE, those questions I have given. Some we have practiced and there are some which are at the end of the video. You have to practice them and write in the comment whether you could solve them or not. So let us see the second example. Here you can find 1,2 diol, a cyclic system where both the rings are 4-membered rings. Now in the same way, first step will be protonation. Here it doesn't matter which carbon is going to form a carbocation. Any one carbon can form a carbocation. either 1 or 2 because it is a symmetric system. So your second carbon undergoes carbocation formation. Okay, there is removal of water group and formation of a carbocation. Now once the carbocation is formed, then the rearrangement will take place. So your next step is rearrangement. And in rearrangement, as we have seen in the previous slide, that when the electrons are shifted, the bond will shift to the 1-2 shift will take place to stabilize the positive charge, and 4-membered ring will expand to 4-member ring expands to 5-membered. Okay, 5-membered ring. And this is your 5-membered ring, 1, 2, 3, 4, 5 after the expansion or 1-2 shift. And the next step is same, to stabilize the positive charge on oxygen by deprotonation, removal of proton, okay, or loss of proton, and you get a ketone, that is pinacolone. So here you can see here the starting material was 1,2-diol containing 4-membered rings, whereas it has means bicyclic ring. This is bicyclic. Yeah, one more thing let me write here. Bicyclic system has converted into spiral system. Such type of system is called as spiral system, where the 2 rings are connected at one common carbon. Such system we call them as spiral system. So what we have got from bicyclic, we have got a spiral system. Okay, so let us go to the next example. So this is the next example where there is a cyclic ring and a cyclic system, both are there in 1,2-diol. Now the question is, which one will first form the carbocation, whether the acyclic or cyclic? So this I have well explained in the previous slides, previous video. As there is inductive effect of both the methyl groups, carbocation will be formed on second carbon. So the protonation will take place on the second carbon OH group, okay, and it was which I have shown here. As you can see, the protonation has taken place, and the next step is removal of water, okay, by formation of, there is one more intermediate which we should show actually. Here what happens is water molecule will be removed and you will get such type of system first. Okay, that is formation of carbocation. Plus sign here, OH, electron shifting takes place and this will shift here, okay, to stabilize it. And this way you can see here, if I write the number of carbons, let us say this is 1, 2, 3, 4, 5. Okay, so we started 1 where there are 2 methyl groups. So let me number here 1, 2. Okay, 2 is one which has O group, double bond O will be formed. So let us number. Students, when you don't understand how to write the product, please write the numbers on the carbon chain so that you can go accordingly. For example, here after shifting of such ring, you don't understand what is the product which is formed. Now here you can see I've labeled it as 1. So my first carbon contains 2 CH3. First carbon contains 2 CH3. Okay. Then second carbon contains double bond O, that is this, with oxygen using its lone pair, it will carry positive charge, and OH. Then it is 3, then 4, then 5. Okay, 5-membered ring. Because this bond, you can see here, this bond has shifted here. So it has expanded. The 4-membered ring has expanded to 5-membered ring, this way. Now the next step is very easy, that stabilization of positive charge by loss of proton. So the proton will be lost and the positive charge will be on oxygen will be stabilized and you will get a ketone. Now students, you should remember that in the first step what we did, we use the proton from acid, and in the last step we give back the proton which we have used. So in a Pinacol-Pinacolone rearrangement, acid proton whatever we have used in the first step is given back to acid in the last step. Okay, and this way we get a expansion of the ring, formation of a ketone which is pinacolone. It is very easy, students. Don't just watch the videos, write down along with me on the paper or in your notebook. So that I always say that organic chemistry is same like mathematics. You have to practice it on the paper. You can't just watch the videos or read them out. You have to do it by pen and pencil, pen and page. Next is, this is one of the most important question which is asked in many competitive exams. Okay students, so you will find a pinacol, which is, if you see the starting material, that is 1,2-diol, you can see here there is a naphthalene, and naphthalene is connected with the diol, 1,2-diol. Okay, somewhat complicated, you can see complex starting material, but don't worry, we are not concerned about the rings here, that is naphthalene ring. We are going to only see how the OH group is going to get protonated first. First step is protonation. Okay, so here as it is a symmetric pinacol, so no worries whether 1 or 2, whichever carbon gets protonated first, it doesn't matter. So second carbon OH is getting protonated and there will be formation of carbocation as we have shown here. So here the second carbon gets protonated and you get a positive charge. Next is 1,2 shift takes place. Okay, now rearrangement will take place. Now in here, as this ring system is closed system and a complex one, the ring will not break from here. Okay, here the ring is not going to, I'll show with the highlighter. Here the ring will not break, the sigma bond will not break, but CH3 group will get shifted from this position to here. So what happens is, you will find when oxygen gives its lone pair, your CH3 group is going to get shifted as a 1,2 shift. So 1,2 shift of methyl group takes place. Methyl group. Just comment below why here the naphthalene bond which was there doesn't break. Just comment in the comment below, students. Why doesn't the ring breaks here at this position? The positive charge on oxygen, last step is our deprotonation. So proton will be removed and you will get back the proton in the acid. The proton will be lost and given back to the acid. So formation of ketone, that is C double bond O, you can find here there is formation of C double bond O, and which is also known as pinacolone. Okay, so this reaction is, this example is asked many times in your competitive exams. Very important. Students, write down this reaction and see on your notebook without fail. Now there are few examples which I have given for practice. Do it in your notebook, and whether you could solve or not, just comment me in the comment box. Okay, so go through this, take a screenshot and write it down in your notebook. Follow whatever instructions I have given in the first video as well as second video. So these are few examples. Go through these. If you go step by step, That is first step, protonation. I'll just write down what are the steps. First step is protonation. Protonation and removal of water molecule. That is formation of carbocation. That is actually the first step. Second step, selectivity. Okay. Selectivity of group for 1,2 shift, that you have to keep in mind. And the third step is deprotonation or loss of proton. So after loss of proton, you will get a ketone. So these, if you follow these 3 steps, you can get all the answers of all these 3. And even in the first video, whatever I have given these for practice, that also you can do it. You can even see the link above to join and see the first video of rearrangement series. Okay, student. So do like the. Thank you for watching rearrangement series part 2. Very soon we are going to upload the next carbocation rearrangement series, that is Beckmann rearrangement. So just, if you like the video, don't forget to share, subscribe ChemONotes for more smart chemistry content. Stay tuned for Beckmann rearrangement, where we will explore another key reaction with same clarity and exam relevance. Until then, keep learning, keep growing, and remember, chemistry is just a concept away. Thank you. Thank you for watching.